Hello chemistry students, here is your ChemQuest 43 corrections about limiting reactants. Limiting reactant, again consider the combustion of propane. If you had 10 moles of propane to burn, you would need 50 moles of oxygen according to the ratio in the balanced equation. If you only had 20 moles of oxygen, you could not combust all 10 moles of propane. The reaction has been limited by the amount of oxygen you have. You don't have enough oxygen to burn all the propane. In this case, oxygen is called the limiting reactant because it limits how much propane can react. Notice that the limiting reactant isn't always the substance that is present in the fewest number of moles. In this example, propane is the excess reactant because after the reaction there will be some of it left over. It is important to remember that everything in a chemical equation is related by mole ratios. If you only know the mass, grams of the substances, you need to convert to moles. In the above discussion, it was evident that 20 moles of oxygen was not sufficient to combust 10 moles of propane. How many moles of the propane can be combusted with 20 moles of oxygen? So if we have 20 moles of oxygen go on the bottom, and moles of propane go on the top. And again, coefficients for our mole ratio. So our coefficient on propane is 1, on oxygen it's 5. So that's going to be 4 moles of propane, okay, are combusted. Or I often use the word used. Letter B. How many moles of carbon dioxide will be produced? Base the answer to this question on the number of moles of propane that actually get combusted, which is your answer to part A. Okay, so you could use that, or the 10 moles, the 20 moles of oxygen. So we had 20 moles of oxygen, and we had 10 moles of propane. And we determined that the oxygen was the limiting reagent. So we should use our limiting reagent to figure out how many moles of carbon dioxide will be produced. Okay. So 20 moles of oxygen. And again, moles of oxygen to moles of carbon dioxide. And coefficient on carbon dioxide is 3, and this is 5. So 20 times 3 divided by 5 is 12 moles of CO2 produced. Now, just to prove to you that it's okay that we did it this way, right? If we do it his way, the problem with his way is that if our answer to this is wrong, our next answer is wrong. Okay, so again, our coefficient is 3, and this is 1, which gives us 12 moles of CO2 produced. So I would prefer that you do it this way, because this way, as long as I use my limiting reagent, or my limiting reactant, I will get the amount of product produced. And if I've made a mistake here, then I would have made a mistake here as well. Letter C. Verify that if 12.5 moles of propane and 63, so we have C3H8 plus 5O2 yields 3CO2 plus 4H2O. I like to put the information underneath my problem. So 12.5 moles of propane and 63.2 moles of oxygen were present, then propane is the limiting reagent and oxygen is the excess reagent. You have two options of how you do this. Option 1, okay, I can take the 12.5 moles of propane and figure out, okay, how many moles of oxygen I need. And we'll do that. And then option 2, and you would only ever do one or the other. You would never ever do both. But I'm going to show you both to prove to you that it doesn't matter which way you do it. You get the same answer either way. Okay? So, we start with our 12.5 moles of propane. Moles of propane go on the bottom. Moles of oxygen go on the top because I'm converting to oxygen. My oxygen coefficient is 5. My propane is 1. So 12.5 times 5 is 62.5 moles of oxygen that we need. Now, how much do we have? We have 62.5. So to burn all of this, I need, and I have, 63.2 moles. So I won't run out of oxygen. Therefore, oxygen is my excess reagent or reactant, and that makes this my limiting reagent or limiting reactant. Okay? So, we just proved that. Let me show you that it wouldn't matter if I did it the other way. If I start with 63.2 moles of oxygen, again, moles of oxygen go on the bottom. Moles of propane this time goes on the top. Again, my coefficient on propane is 1. On oxygen, it's 5. So I'm going to do 63.2, and I'm going to divide it by 5, and I get, we'll say 12.6 moles of propane that I need. Now, notice I only have 12.5 moles. Therefore, I'm going to run out of the propane. Therefore, propane is my limiting reactant. So it doesn't matter which way you do it. Okay? Either way, you get the same answer. Number 2, consider the following chemical reaction. Assume that 0.75 moles of magnesium chloride and 0.65 moles of sodium phosphate are placed in a reaction vessel. Verify that the sodium phosphate is the excess reactant and magnesium chloride is the limiting reactant. Again, it doesn't matter which way you choose to do this. Okay? And again, you would only do one way. So I'm just going to choose to take my 0.75 moles of magnesium chloride and figure out how many moles of sodium phosphate I need. So I start with my 0.75 moles. Moles of magnesium chloride go on the bottom, so they'll cross out. Moles of the sodium phosphate go on the top. This is a mole ratio, so it's my coefficient. So sodium phosphate's coefficient is 2. Magnesium chloride's coefficient is 3. 0.75 times 2. Divide that by 3, and I get 0.5. I want 2 sig figs, so 0.50 moles of sodium phosphate that I need. Now notice I have, right, 0.65 moles of sodium phosphate. Therefore, I won't run out. Therefore, it's the excess reactant, which means magnesium chloride is my limiting reactant. Now, how many moles of excess reactant are left over after the reaction stops? Well, if you had not done this, you'd have to do this math. But this has how many moles are left over after the reaction stops. So I have 0.65 moles I'm going to use 0.5 moles okay, which equals 0.65 minus 0.5, right? 0.15 moles of sodium phosphate will be left over unreacted. How many moles of sodium chloride will be produced in this reaction? Remember, you must base this answer on how many moles of the limiting reactant that reacted. So I'm going to start with my limiting reactant for this one. So this one is asking me to take, okay, the 0.75 moles of magnesium chloride and figure out how many moles of sodium chloride I produce. And I know I have to use the magnesium chloride because I have to use my limiting reactant to calculate the amounts of my products. So I start with my 0.75 moles of magnesium chloride. Moles of magnesium chloride go on the bottom so that they'll cross out. I'm going to do moles of sodium chloride on the top. Again, my coefficient on sodium chloride is 6. My coefficient on magnesium chloride is 3. I can't reduce that. I do need to actually use those numbers. So 0.75 times 6 divided by 3, right? And I get, with two significant figures, 1.5 moles of sodium chloride that I produce. Number 3, consider the double replacement reaction between calcium sulfate and sodium iodide. If 34.7 grams of calcium sulfate and 58.3 grams of sodium iodide are placed in a reaction vessel, how many grams of each product are produced? Hint, do this problem in the steps outlined below. We're not going to necessarily do that. We're going to do it kind of Mrs. K's way. But first thing we need for all stoichiometric calculations is a balanced chemical equation. So we have calcium sulfate reacting with sodium iodide. It's a double replacement reaction, so calcium and sodium are alike. So these are ionic compounds. Calcium has a +2 charge, iodide has a -1, so it's CaI2 plus sodium has a +1 charge, sulfate has a -2 charge, and Na2SO4. Balancing this, I need a coefficient of 2 on sodium iodide. Now, this tells me I have 34.7 grams of calcium sulfate and 58.3 grams of sodium iodide. We're not going to worry about these. We're going to do it Mrs. K's way, which means all in one step, okay? So, again, I have two options here. Option 1, to figure out my limiting reagent. I can take my 34.7 grams of my calcium sulfate and figure out how many grams of sodium iodide I need. I want to use grams because both of my amounts are given in grams. Option 2, and I'm going to show you option 2. Remember, you would never ever do both. I can start with my 58.3 grams of sodium iodide and figure out how many grams of calcium sulfate I need. Okay, to figure out my limiting reagent. And then notice this is asking how many grams of each product are produced. So, going the first way, 34.7 grams of calcium sulfate. I'm going to use the molar mass of calcium sulfate to convert it to moles, and I'm going to do all those calculations at the end. Moles of calcium sulfate to moles of sodium iodide using my mole ratio. Moles of sodium iodide to grams of sodium iodide using the molar mass. So, need my periodic table. Again, 1 mole, and for this I'm going to use my periodic table, so it's calcium, which is 40.078. plus sulfur, which is 32.065, plus 4 oxygens at 15.999. So that's 136.139 grams. Now, here, this is my mole ratio. These are my coefficients. So 2 is my coefficient on sodium iodide, and 1 is my coefficient on calcium sulfate. This is a molar mass again. So I need 1 sodium, which is 22.99, and I need 1 iodide, which is 126.9. So I get 149.89. So now I'm ready to do the math. Okay. So 34.7 times 2 times 149.89, so multiplying by everything in the numerator and dividing by what's in the denominator. Okay, and I want to use 3 sig figs, so I have 76.4 grams of sodium iodide I need. Now, I have 58.3 grams. So am I going to run out of it? Yes. Therefore, sodium iodide is my limiting reactant. Now, again, I want to show you that it wouldn't matter. You would never ever do both. I'm doing both to show you that it doesn't matter which one I start with. Now, what's nice is the numbers I already calculated, right, are still the molar masses. So 149.89 grams of sodium iodide to 1 mole of sodium iodide, because I have to convert grams to moles. I'm going to use my mole ratio to take moles of sodium iodide to moles of calcium sulfate. And again, the numbers for that come from my coefficient. So calcium sulfate is 1, sodium iodide is 2. Moles of calcium sulfate to grams of calcium sulfate, which is the 136.139. Okay, so 58.3 times 136.139 divided by, I need parentheses because I have 2 things to divide by. Okay, notice I get, again, I want 3 sig figs, 26.5 grams of calcium sulfate that I need. Notice I have 34.7 grams of calcium sulfate. So I won't run out. Therefore, calcium sulfate is my excess reactant, which means then my other reactant has to be my limiting. So my limiting reactant, my excess reactant. Now, we haven't actually answered the question. And again, remember, we'd only do this one of these ways. We would never do both. But now we need to answer the question, which is, we want to know how much of each product. That's 2 separate calculations. But again, remember, I have to start with my limiting reactant. So I'm going to start with the 58.3 grams of sodium iodide. Again, my numbers I already calculated for my molar mass are not going to change, so I can just use them. So I'm using molar mass to convert to moles. I'm going to use my mole ratio, and I'm going to go to calcium iodide first, so moles of calcium iodide. Again, these are my coefficients, so this is 1 and this is 2. And then I'm going to use my molar mass of calcium iodide to calculate the mass. So again, I need my periodic table. Calcium is 40.078, and there is 2 iodines at 126.9 each. So that gives me a mass of 293.878 grams. So now to do this calculation, right, 58.3 times 293.878 divided by the 149.89 times 2. I put that in parentheses, and I should have 3 sig figs, so 57.2. grams of calcium iodide. So that's one of my products. I want to calculate the mass of my other product. So again, I still have to start with my limiting reactant, which is my sodium iodide. Again, I'm going to use my molar mass to convert to moles. I'm going to use my mole ratio to convert to my other compound, which is my sodium sulfate. And then I'm going to use the molar mass of sodium sulfate to convert to its grams. Again, this is still my 149.89. These are my coefficients. So for sodium sulfate, my coefficient's 1. For sodium iodide, my coefficient's 2. This is 1. And again, this is going to come from adding up my 2 sodiums, 22.99 times 2, plus 1 sulfur, 32.065, plus 4 oxygens. I get 142.041 grams. So now I'm ready to do this calculation. So I'm going to take that number and multiply it by 58.3 and divide that by 149.89 times 2. Okay. And again, I want 3 significant figures, so I get 27.6 grams of sodium sulfate that we produce. Number 4. If 181.1 of aluminum nitrate react with 102.1 grams of calcium oxide, double replacement reaction, how many grams of each product will be produced? Note, this is just like the last one. So we first need a balanced chemical equation. So AlNO3 plus CaO, this is double replacement. Aluminum and calcium are alike, so aluminum plus 3, oxygen negative 2, so it's Al2O3 plus calcium plus 2, nitrate is negative 1. These are all ionic compounds, 2. So I have 2 aluminum, so I need a coefficient of 2. I have 6 nitrate, so I need a coefficient of 3. I have 1 calcium, I have 3 calcium, so I need a coefficient of 3. I have 3 oxygens, I have 3 oxygens, so it's now balanced. Now, again, 181.1 grams of this and 102.1 grams of this. We want to know how many grams of each product are produced. Again, I'm not going to do it both ways. You guys, I've told you before I'm linear. I am always going to start here and convert to that one. You don't have to do it that way. I've shown you now a couple times. It doesn't matter. So to determine the limiting reactant, I'm going to take 181.1 grams of aluminum nitrate and figure out how many grams of calcium oxide I need. So 181.1 grams of aluminum nitrate, molar mass, to convert to moles, moles of aluminum nitrate to moles of calcium oxide, moles of calcium oxide to grams of calcium oxide using molar mass. That's 1. These mole ratios come from my coefficient. My coefficient is 3. My coefficient is 2. All right. Figuring out these masses, right? Aluminum, 26.982, plus I have 3 nitrogens, plus I have 9 oxygens. So 212.994. Okay. For calcium oxide, calcium is 40.078. Okay. Oxygen is 15.999. And so this is 56.077. So now I'm ready to do the calculation. So I'm going to take 181.1 times 3 times the 56.077. I'm going to divide that answer by the 212.994 times 2, so I put it in parentheses. I want 4 significant figures, so 71.52 grams of calcium oxide I need. Now, notice I have 102. Therefore, I'm not going to run out. And calcium oxide is my excess reactant. Therefore, the aluminum nitrate is my limiting reactant. So this is my limiting reactant. This is my excess reactant. So now I'm ready to calculate my amount of product. I have to use my limiting reactant. So 181.1 grams of aluminum nitrate. Again, what's nice is that mass is going to be used again, so 212.994 grams of aluminum nitrate to 1 mole. Moles of aluminum nitrate to moles of my first product, which is aluminum oxide. Those are my coefficients, so my coefficient is 1 and my coefficient is 2. Moles of aluminum oxide to grams of aluminum oxide using my molar mass. So I need to calculate that number. So aluminum is 26.982, and there's 2 of them, plus 3 oxygens at 15.999. Oops, too many 9s. And I get 101.961 grams to 1 mole. So I'm going to take that and multiply that by the 181.1. And then I'm going to divide that by the 212 times 2. And I want 4 significant figures, so I have 43.35 grams of aluminum oxide that I produce. And now I need to do the same thing, but for calcium nitrate. So, okay. 181.1 grams of aluminum nitrate. It's molar mass. Okay, I'm writing the wrong formula though. To 1 mole. Again, moles of aluminum nitrate on the bottom. This time moles of my calcium nitrate on the top. Again, my coefficient's 3 and my coefficient is 2 from my balanced chemical equations up here. 1 mole of calcium nitrate is how many grams of calcium nitrate? Okay, and again, that's going to be 1. So again, I need to calculate that number. So for calcium, it's 40.078, and there's 1 plus 2 nitrogens plus 6 oxygens. So 164.086. So now I'm ready to do this calculation. Okay. 181.1 times by 3 times by 164.086. I'm going to divide that by my 212.994 times by 2. And again, I want 4 significant figures, so I'm going to get 209.3 grams of calcium nitrate that I produce. So the important thing here is when you're asked to calculate the amounts of products, you always have to use your limiting reactant to calculate the amount of product. Have a great day. I'll talk to you tomorrow.